Hello everyone, this is second part of past year CAT questions from the topic permutation and combination. It is observed that students are ignoring this topic because there was not a single question in any of the slot of CAT 2023 from this topic. But let's not forget that CAT is a very unpredictable exam. Next year also it is possible that there will not be any question from this topic, and equally it is possible that there will be a considerable number of questions from this topic. So let's not ignore this. In the first part we started with the questions from the old CAT papers. Around 11 to 12 questions we solved over there. Before you continue with this video, make sure that you revise all the concepts of permutation and combination. And second thing is, whenever the question is displayed on the screen, pause the video, solve that question by yourself, and then continue with the video. So let's start with the second part of past year CAT questions from the topic permutation and combination. The first question is from CAT 1999. For a scholarship, at most n candidates out of 2n plus 1 can be selected. If the number of different ways of selection of at least one candidate is 63, the maximum number of candidates that can be selected for the scholarship is how much? So over here, total number of candidates are 2n plus 1. Out of these many candidates, minimum we can choose one candidate. Then we can choose out of 2n plus 1, we can choose 2 candidates. Then out of 2n plus 1, we can choose 3 candidates, and so on. And out of 2n plus 1, maximum how many candidates we can choose? Maximum n candidates we can choose. The addition of these terms is equal to 63 over here. Now the question is maximum number of candidates that we can select. The question is we need to find the value of n over here. Maximum we can choose n candidates out of 2n plus 1. So now we need to find the value of n. How we can find? Let's have a look at it, everyone. Over here we need to take a help of the formula. Which formula I am talking about? nc0 plus nc1 plus nc2 till ncn. This addition is equal to how much? This addition is equal to 2 to the power n, everyone. So over here, total number of candidates are 2n plus 1. So let's concentrate here. Out of 2n plus 1, let's say we are choosing 0 candidates. Then out of 2n plus 1, we are choosing 1 candidate. Then out of 2n plus 1, we are choosing 2 candidates, and so on. Then out of 2n plus 1, we are choosing n candidates. Then out of 2n plus 1, we are choosing n plus 1 candidates. Then out of 2n plus 1, or hold on, and so on. Then out of 2n plus 1, we are choosing all 2n plus 1 candidates. This addition is equal to how much? 2 to the power 2n plus 1, everyone. So over here, let's understand one thing. The one more formula that we are supposed to use here is the value of NCR is equal to the value of NCn minus R. So what you can conclude, everyone, here? The value of 2n plus 1 C0 is equal to value of 2n plus 1 C2n plus 1. Okay. Similarly, the value of 2n plus 1 C1 is equal to 2n plus 1 C2n. Similarly, what you can say that the value of 2n plus 1 Cn, the value of this, the value of 2n plus 1 Cn is equal to the value of 2n plus 1 C, 2n plus 1 minus n, that is n plus 1. So from this, what we can conclude, everyone? From this, what we can conclude, the value of this and the value of this is going to be same. Okay, this addition is going to be symmetrical. The first term and last term is equal, second term and second last term is equal, third term and third last term is equal, everyone. So what is the addition of these terms, everyone? The value of 2n plus 1 c0 is 1, and the sum of 2n plus 1 c1 till 2n plus 1 cn, this sum is equal to 63. The value of these terms is equal to 64, so the value of these terms is also 64. So 64 plus 64 is equal to 128. So 128 is equal to 2 to the power 2n plus 1, which is equal to 2 to the power 7. So the value of 2n plus 1 is equal to 7. So if you solve this further, you will get n is equal to 3. So the maximum number of candidates that we can select is 3 over here. This is how we can solve this question. The next is question number 36. Depending on this data, there are two questions, question number 36 and question number 35. So the data is each of the 11 letters appears when looked at in a mirror. They are called symmetric letters. Other letters are called as asymmetric letters. So question number 36 is, how many 3-letter computer passwords can be formed without repetition with at least one of the symmetric letters? So let's have a look at it. At least one of the symmetric letter. What is the opposite of at least one of the symmetric letter? That none of them is a symmetric letter. That all of them are asymmetric letters. So how many passwords you can find? So total number of passwords are going to be how much? Let's have a look at it. Total number of 3-letter passwords without repetition is equal to, out of 26 letters, choose 3 letters and the arrangement of those 3 letters. These many 3-letter passwords are possible without any condition. Now, how many 3-letter passwords you can form where all the letters used are asymmetric letters? So out of 26, 11 are symmetric, the remaining 15 are asymmetric. So out of 15, let's choose 3 and then 3 factorial. These are the 3-letter words in which there is no any symmetric letters are used. So now what is our question? We want at least one symmetric letter. So our answer is going to be how much? Total number of passwords is equal to 26c3 into 3 factorial minus the number of passwords in which none of the letter is symmetric, that is 15c3 into 3 factorial. So let's solve this. This is going to be how much? 26, 25, 24 divided by 3 into 2 into 1, or you can say divided by 3 factorial into 3 factorial, minus 15c3 is 15 into 14 into 13 divided by 3 factorial then into 3 factorial. So this 3 factorial and 3 factorial will get cancelled out from here. So now let's solve this. So what you can take common, everyone? You can take 13 common, okay? If you take 13 common, over here 2 is remaining, over here 1 is remaining. If you take 5 common, over here 5 is remaining, over here 3 is remaining. If you take 2 common, over here 14 is, over here 12 is remaining, over here 7 is remaining, everyone. So this multiplication is going to be how much? 130 into this subtraction is how much? This subtraction is 120 minus 21. That is equal to 130 into 99, everyone. So 130 into 99 is 100 minus 1. So what is our answer over here? 13,000 minus 130. That is equal to option C, 12,870 is the final answer of this question number 36. The next question is, by using the same data, how many 4-letter computer passwords can be formed using only symmetric letters without repetition? So what we are supposed to do over here, that out of 11 symmetric letters you need to choose 4 symmetric letters, and then you can arrange those 4 letters in 4 factorial ways, everyone. So this is our answer here. This is going to be how much? 11 into 10 into 9 into 8 divided by 4 factorial into 4 factorial. This 4 factorial will get cancelled out, and our answer is 110 into 72. So this multiplication is going to be how much? This multiplication is going to be 7200 plus 720. That is equal to 7920. The answer is option A. The next is from the question from CAT 2002. 10 straight lines, no 2 of which are parallel and no 3 of which passes through any common point. They are drawn on a plane. The total number of regions, including finite and infinite regions, into which the plane would be divided by the lines is how much? So if I draw only one line, you can see if the number of lines is 1, then the number of regions are going to be 2. These are the 2 regions over here. If I draw 2 lines, then the number of regions are going to be 4. These are the 4 regions. If I draw 3 lines, in that case the number of regions are going to be 1, 2, 3, 4, 5, 6 and 7. So over here there is a formula. What is the formula? If the number of lines are n, the formula to find the maximum number of regions, hold on, is equal to n into n plus 1 divided by 2 plus 1. For example, if the number of lines are 3, 3 into 4 divided by 2 plus 1. This is how we can find the number of regions, maximum number of regions. So over here the answer is total 10 lines are drawn over here, that is 10 into 11 divided by 2 and then plus 1. So 55 plus 1, 56 is the answer to this question. The next question is from CAT 2002. If there are 10 positive real numbers such that n1 is less than n2 is less than n3 is less so on less than n10, how many triplets of these numbers n1, n2, n3, n2, n3, n4 can be generated such that the first number is always less than second number and the second number is always less than third number? So let's say we are supposed to choose 3 numbers a, b and c such that first number should be less than second number and second number should be less than third number. So from this what we can conclude, everyone, the value of a cannot be equal to b, the value of b cannot be equal to c. A, b, c are supposed to be distinct. So we want to choose 3 numbers. Out of 10 numbers we are supposed to choose 3 numbers, everyone. In how many ways we can do this? 10 into 9 into 8 divided by 3 into 2 into 1. That is equal to how much? That is equal to 120. There are 120 ways in which we can choose 3 numbers. So let's say I selected 15, 9 and 17. So I want smallest number first, second smallest number second position and the remaining number at a third position. So in how many ways we can arrange according to our condition, everyone? The first number should be less than second number and second number should be less than third number. That is 9 is less than 15 and 15 is less than 17. This is the only possible combination. So total there are 120 ways in which we can choose 3 numbers out of 10 numbers, and for every way there is only one way where we can arrange them in the ascending order. Okay, choose any 3 numbers, there is going to be only one way where they are in the ascending order. So the answer of this question is 120 ways into 1, that is equal to 120 is the final answer of this question number 33. 32. A graph may be defined as a set of points connected by lines called as edges. Every edge connects a pair of points. Thus a triangle is a graph of 3 edges and 3 points. The degree of a point is the number of edges connected to it. For example, a triangle is a graph with the 3 points of degree 2 each. For example, you can see in triangle every vertex is connected with 2 edges. Every vertex is connected with 2 edges, so the degree of each vertex is equal to 2. Consider a graph of 12 points. It is possible to reach any point from the any point through the sequence of edges. It is possible to reach from any point to any other point through the sequence of edges. The number of edges in the graph must satisfy which of the following condition. So let's have a look at it. The minimum number of edges are going to be how much? Minimum number of edges. Total there are 12 points are there. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The minimum number of edges to connect these 12 points is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So 11 is the minimum number of edges. To connect any two points, we can travel from any point to any other point through the sequence of edges. And what about the maximum? What about the maximum number? So there are total 12 points are there. The maximum how many lines, maximum how many edges you can draw. With the help of these 12 points, to draw edge we need any 2 point. In how many ways you can choose 2 points out of 12 points, everyone? 12 into 11 divided by 2, that is equal to 66 is a maximum number of edges. The minimum number of edges is 11 and 66 is the maximum number of edges. So which option satisfies over here? Option A is correct option. The next question is from CAT 2003. There are 6 boxes numbered 1 to 6. Each box is to be filled up either with a red ball or a green ball in such a way that at least one box contain a green ball. At least one box contain a green ball, and the boxes containing green ball are consecutively numbered. In how many ways we can do this? Let's have a look at it. So basically there are 6 distinct boxes are there. So let's call boxes as B1, B2, B3, B4 and B5 and then B6. In every box there is a one ball. That ball is of red color or that ball is of green color. Okay. And all the green color boxes, all the boxes having green color ball, they are consecutively numbered. So let's have a look at it. So over here, number of boxes having green ball and the number of boxes having red ball. Let's say one box is having green ball and the 5 boxes are having red ball. In how many ways we can do this, everyone? One ball is having green ball and the remaining boxes are having red ball. So over here, out of 6 boxes, choose one box. Over there, put green ball, everyone. And in the remaining boxes, put red ball. In how many ways we can do this? In 6 ways we can do this. Which 6 ways, everyone? The first way is green ball is in bag 1, second case green ball is in bag 2, third case green ball is in bag 3. Then second case, the out of total 2 boxes are having green ball and the 4 boxes are having red ball. So let's have a look at it. So over here, 2 consecutive boxes are having green ball and the remaining 4 boxes are having red ball. In how many ways we can do this, everyone? Over here, those 2 consecutive boxes can be B1, B2, B3, B4, B1, B2, B2 B3, B3 B4, B4 B5 and B5 B6. So out of these 6 boxes you need to choose 2 consecutive boxes. In how many ways you can do this, everyone? 1 2 3 4 5. There are 5 ways you can do this. Out of these 6 boxes, choose 2 consecutive boxes, put green ball over there, and in the remaining boxes put red ball. In how many ways you can do this, everyone? In 5 ways you can do. The next is, let's say there are 3 boxes. Let's say there are 3 boxes having green ball and the remaining 3 boxes will have red ball, everyone. So we want green ball in 3 consecutive boxes and the remaining 3 boxes is going to be red, red and red. So over here we need to choose 3 consecutive boxes. That can be B1 B2 B3, that can be B2 B3 B4, that can be B3 B4 B5, that can be B4 B5 B6. In how many ways you can choose 3 consecutive boxes out of these 6 boxes, everyone? 1 2 3 4 ways. There are 4 ways of doing this. Now let's say there are 4 boxes having green color ball and the remaining 2 boxes are having red color ball. So out of these, total 4 boxes we want green color, remaining 2 boxes red color, everyone. So we need to choose 4 consecutive green boxes. This is first possibility, second possibility and third possibility. There are 3 possibilities in which you can put a green ball in 4 consecutive boxes. So likewise you need to make the cases over here. The next possibility is green ball is available in 5 boxes, red is available in 1 box. That in how many ways you can do this, everyone? Look here, green ball is available in 5 consecutive boxes, remaining 1 ball is red. So in how many ways you can choose 5 consecutive boxes for the green color? This is one way, this is second way, everyone. There are 2 ways of doing this. And the last possibility is, out of the total boxes, all 6 boxes are having green color and 0 boxes are having red color. So this is possible with only one combination, everyone. All 6 balls are having green color, okay. All 6 bags are having green color. In how many ways you can do this? You can do this in only one way. So total number of ways of doing this is equal to how much, everyone? Addition. 6, 5, 4, 15, 20 and 21. That is option B is the correct answer over here. The next is question number 30 from CAT 2003. How many 3-digit positive integers with the digits x, y, z in 100th place, tens place and units place, x, y and z, such that we want x to be less than y, everyone, and z to be less than y. X cannot be equal to 0. So how many 3-digit numbers we can form, everyone? We know that x is less than y, we know that z is less than y, but we don't know among x and y which one is greater, which one is smaller. That we don't know. So over here we need to make the cases. Let's have a look at it. Over here we need to make the cases x and z, these numbers are less than y, everyone. Okay. So if you put hold on, we know that x and z, they are less than y. Okay. So if you put y is equal to maximum value that y can take is 9, everyone. The maximum value y can take is 9 because it is digit. In that case, the value of x is going to be how much? Nothing is mentioned about repetition, so the repetition is allowed. The value of x cannot be 0. The value of x has to be less than 8. Okay, less than 9. So the possible values of x are 1 to 8. There are 8 choices. The value of z can be 0. Okay, and value of z is going to be how much? 0 to 8. There are 9 choices. So 72 combinations are possible over here if y is equal to 9. Similarly, over here the value of x and z can be same as well. Now the next is if y is equal to 8 everyone, then the value of x and z should be less than 8. The value of x is going to be 1 to 7, 7 choices. Value of z 0 to 7, there are 8 choices, 56 numbers are possible over here. Now if you put y is equal to 7, then value of x is going to be 1 to 6 possibilities. Value of z is going to be 0. For z 0 is applicable. 0 to 6, that is equal to 7 choices, total 42. After that, if the value of y is equal to 6, x can be 1 to 5, 5 choices, z is 0 to 5, 6 choices. Then if you put y is equal to 4, value of x is going to be 1 to 4, that is 4 choices, 1 to 3, that is 3 choices, okay? Because the value of y is 4, x and z are supposed to be less than 4, 1, 2 and 3, 3 choices. The value of z can be 0, 1, 2 and 3, 4 choices, okay? 12 numbers are possible over here. If the value of y is equal to 5, then the value of x can be what? Value of x can be 1. The value of x should be, x and z should be less than 5. It can be 1, 2, 3. Hold on, this y is equal to 5 I missed over here, okay? So y is equal to 5. X can be 1, 2, 4, 4 choices. Z can be 0, okay? Z can be 0 to 4, 5 choices. 20 numbers are possible over here. So hold on, let me rearrange this over here. The next is what will happen if y is equal to 3. Let's have a look at it. What will happen if I keep y is equal to 3, x and z are supposed to be less than 3. X can take value 1 or 2, 2 choices. Z can take 0, 1 and 2, 3 choices, okay? If I consider value of y to be 2, the value of x and z should be less than 2. Value of x is 1, this is the only possibility. Value of z can be 0 or 1, 2 choices everyone. So 2, okay? If you put value of y to be 1, okay everyone? Value of y to be 1 over here. Is there any possibility for x and y? Let's check everyone. X and z, they are supposed to be less than y. Means they are supposed to be 0 and 0, but x cannot be 0, so there will not be any number satisfying the condition. So your answer is this addition everyone. Let's do this addition. 30 plus 20, 50, then 60, then 70, okay? 70, hold on, let me do this addition again. 30, 40, 50, 60 and then 70, okay? 70 and 42 is 112 and 72 plus 56 is equal to 128. So this addition is equal to how much? This addition is equal to 240 everyone, that is option C. Question number 28 and 29, they are dependent on the given data. A string of 3 English letters is formed as per the following rules. The first letter is any vowel, second letter is M or N or P. Then if the second letter is M, then what will happen if the second letter is N and if the second letter is P? So let's read question number 28. How many strings of the letters can possibly formed by using the above rules? So let's have a look at it. So over here what we'll do is, let's make 3 cases. The first case is the second letter is M. What will happen over here? If I fix second letter as M, the first letter is going to be If the second letter is M, then the third letter is any vowel which is different than the first letter, everyone. So the first letter is going to be A, E, I, O, U. So there are 5 choices over here, there is 1 choice over here, and the third letter is any vowel which is different than the first letter, everyone. It means total there are 4 choices are here. So if a second letter is M, total 23 letter words you can form. Now if the second letter is N, then what will happen, everyone? Third letter is either E or U, and the first letter is any vowel, A, E, I, O, U. Nothing is mentioned about the repetition. So the repetition is allowed. For the first place 5 choices, second place 1 choice, and the third place there are 2 choices. So total 10 3-digit number, total 10 3-digit words are possible, everyone, here. And the third case is the middle letter, the second letter is P. In that case the third letter is same as the first letter, everyone. For the first letter there are 5 choices are there, A, E, I, O, U. There are 5 choices for the first letter, 1 choice for the second letter. And for the third letter also there is only 1 choice, because first and third letter are supposed to be same. So in the third case total there are 5 3-letter strings we can form. So the final answer of this question is going to be how much? 20 plus 10 plus 5, that is 35 is the final answer to this question. And I guess that is, hold on, that is option D, everyone. So this is how we can solve this question number 28. The next is question number 29, depending on the same data. The question is, how many strings of letters can possibly be formed using the above rule such that the third letter is E? So now look here. Over here the first case is second letter is M, third letter is E. Then second case is second letter is N, third letter is E. And the third case is second letter is P and the third letter is E. So let's have a look at it, everyone. The first place can be any vowel, A, E, I, O, U. If a second letter is M, then the third letter is any vowel which is different than the first letter, everyone. It means the third letter is E. So the first letter cannot be E now. So for the first letter there are 4 choices. Second letter 1 choice, third letter 1 choice. So over here total 4 strings are possible. Now if the second letter is N, the third letter is supposed to be E or U. Okay, 1 choice, 1 choice, and first place can be any vowel, A, E, I, O, U. So total 5 choices are there. So over here the answer is 5. Third case, when the middle letter is P, when the second letter is P, the third letter is same as the first letter. If the third letter is E, the first letter is also supposed to be E. So there is only 1 choice here, 1 choice here, 1 choice over here. So total only 1 word we can form over here. So what is the answer of this question? 4 plus 5 plus 1, that is equal to 10. The answer is option number C. The next question is from CAT 2003. There are 12 towns grouped into 4 zones with 3 towns per zone. Let's have a look at it. These are 4 zones. In each zone there are 3 towns. So let's call this as zone 1, 2, 3 and 4. It is intended to connect the towns with a telephone line such that every two towns are connected with three direct lines if they belong to same zone, and one direct line if they does not belong to the same zone. How many direct telephone lines are required? First of all, within zone 1, let's have a look at it. Within zone 1, how many telephone lines, how many direct lines do we require, everyone? Every two towns are connected with three direct lines. So in zone 1 there are three towns. Out of these three towns you need to choose two towns, and for that pair of two towns there are three direct lines are there. So how many direct lines we require in zone 1? 3C2 3 into 3, that is equal to total 9 direct lines we require. For example, look at these two towns are connected with three direct lines, these two towns are connected with three direct lines, these two towns are connected with three direct lines. So total 9 direct lines are required in zone 1. Similarly in zone 2, zone 3 and zone 4. Okay, total 9 direct lines are required, that is 9 into 4 is 36, everyone. This is within zone. Okay, now outside zone. Okay, so this town, let's call this town as a town A, everyone. Let's talk about town A of zone 1. This town will get connected with 3 and 3, 9 towns, everyone. Okay, with a single line. So every town of zone 1 will be having 9 direct lines with the other towns of other zones, everyone. So this is B, this is C. Town B of zone 1 require 9 direct lines for the towns which are outside zone 1. Similarly, town C of Z1 require 9 direct lines with the towns which are in other zones. So total 9, 27, everyone. Zone 1 is already connected with zone 2, zone 3 and zone 4. This is the connection of zone 1 with zone 2, zone 3 and zone 4. Okay, everyone. So now the connection of zone 2 with zone 3 and zone 4, everyone. Let's have a look at it. Now this town, let's call this town as P. Town P is already connected with the towns of zone 1. Now town P is supposed to get connected with the towns in zone 3 and zone 4. That is total 6 towns, so 6 lines. This is town Q requires 6 another direct lines. This is town R requires 6 another direct lines. 6 plus 6 plus 6 is 18. So zone 2 is connected with zone 3 and zone 4. Now the connection of zone 3 is already done with zone 1 and zone 2. Now zone 3, the connection is remaining with zone 4. So let's say this is KLM. Town K of zone 3 will get connected with all 3 towns of zone 4. So 3 direct lines. Then town L of zone 3 will get connected with 3 towns of zone 4 by using 3 another direct lines. Same for town M, 3 another direct lines. Such that zone 4 is now already connected with zone 1, zone 2 and zone 3. So total number of direct lines that we need over here are how many? 36, 27, 18 and 9. This addition is equal to how much? 36 plus 81. Sorry, this addition is equal to how much? 36 plus 54. That is equal to 90 is the final answer to this question. The next question is from CAT 2004. A new flag is to be designed with 6 vertical strips using some or all the colors yellow, green, blue and red. Total 4 colors are there. Then the number of ways this can be done so that no 2 adjacent strips have the same color. So look here, total there are 6 vertical strips are there like this. 1, 2, 3, 4, 5 and 6. For the first strip we are having a choice of 4 colors. For the second strip, total 4 colors are available. Out of these 4 colors we cannot use one color which already used over here, so we left with choice of 3 colors. For the third strip, total 4 colors are available. We cannot choose the color which used in the second strip. We can use the color of first strip, but we cannot use the color used in the second strip. So again there are 3 choices are there. For the fourth strip, total 4 colors are available. We cannot use the color used in the third strip, but we can use the color used in the first and second strip. So out of these 4 colors, only one color we cannot use. So over here 3 choices. Over here again there are 3 choices. Over here again there are 3 choices. So the answer of this question is 4 into 3 to the power 5. So 4 into 3, 12 into 81 is the correct answer over here. Option A is the correct answer.